Hello and welcome to Electrical Guru Karan channel. In this short reel I'll explain, step by step, how electricity is produced in a power plant. Read naturally, pause where indicated, and imagine matching visuals, diagrams, animated flow, and live footage. Let's start. Step 1. The big idea. Electricity generation is a chain of energy conversions. A power plant takes energy stored in fuel or nature, converts it to mechanical motion, and then converts that motion into electrical energy using electromagnetic induction. In plain words, something spins a generator, and the generator makes electricity. Step 2. Picking the energy source. Power plants use different primary energy sources. Common types are fossil fuels like coal, oil or natural gas, nuclear fuel, flowing water in hydroelectric dams, wind in wind farms, and sunlight in solar installations. Each source delivers energy differently, but all aim to create rotation, that mechanical motion needed for a generator. Step 3. Creating heat or motion. In thermal and nuclear plants, chemical energy or nuclear fission produces heat. That heat boils water in a boiler to make high-pressure steam. In hydro plants, stored water releases potential energy and becomes fast-moving water. In wind farms, wind turns blades directly. In solar photovoltaic plants, sunlight is converted straight into electricity without spinning turbines, but for most large plants, turbines and steam or kinetic flow are central. Step 4. The turbine, converting fluid energy to rotation. The turbine is a rotor with many blades. High-pressure steam, flowing water or wind strikes these blades and makes the rotor spin. Turbines are designed to extract as much energy as possible from the fluid flow and rotate at high speeds that match the generator's needs. Step 5. The generator, mechanical to electrical. A generator contains a rotating part called the rotor and stationary coils called the stator. As the rotor spins, it creates a changing magnetic field. Faraday's law of electromagnetic induction says that changing magnetic fields induce voltage in nearby coils. That induced voltage produces alternating current, AC, which is the electricity a plant delivers. Step 6. The steam cycle and recycling water. In steam plants, the process is usually a closed loop. After steam passes through the turbine and expands, it enters a condenser where it cools and turns back into water. Pumps return this condensate to the boiler. Recycling water conserves resources and keeps the plant running continuously. Step 7. Conditioning power with transformers. Electricity from the generator is at a voltage convenient for the generator but not ideal for long-distance travel. Transformers step up the voltage to very high levels for transmission. Higher voltage means lower current for the same power, and since line losses are proportional to the square of current, stepping up voltage dramatically reduces energy losses in transmission lines. Near demand centers, other transformers step voltage down to safe distribution levels. Step 8. Transmission, substations and distribution. High voltage electricity travels along transmission lines to substations. Substations contain switchgear, transformers and protection devices to route and manage power. From substations, distribution lines deliver electricity at lower voltages to neighborhoods. Local transformers on poles or pads perform the final step down so homes and businesses get usable voltages. Step 9. Control, protection and grid stability. Power plants and grids use sophisticated control systems, governors, automatic regulators and SCADA to keep frequency and voltage stable. Protection systems like relays and circuit breakers isolate faults quickly. Operators coordinate generation and demand in real time so supply always matches consumption. Step 10. Efficiency improvements and combined cycles. Modern plants boost efficiency with superheated steam, reheaters, and combined cycle systems. In combined cycle plants, waste heat from a gas turbine produces steam for a steam turbine, greatly increasing overall efficiency and reducing fuel use and emissions. Step 11. Environmental and practical considerations. Different plant types bring different impacts. Fossil-fueled plants emit CO and pollutants if uncontrolled. Nuclear plants produce radioactive waste that requires secure management. Large hydro affects river ecosystems. Wind and solar have low emissions but require land and intermittency solutions. Today's grids mix sources, storage and demand response for reliability and cleaner power. Summary from source to socket. To summarize, energy starts as fuel or natural motion, becomes heat or kinetic flow, spins turbines, drives generators, gets voltage conditioned by transformers, travels through transmission and distribution networks, and finally powers devices at your home. Control and protection systems keep the whole system stable and safe. Closing call to action. Thank you for watching Electrical Guru. If you liked this clear, step-by-step guide,